In this video, we're going to take a look at what is called logarithms. And you've probably heard of a logarithm before, and you might even be a little bit afraid of logarithms, but you shouldn't be, because they're actually a very simple concept. To start out, think about multiplication. Multiplication has an inverse operation called division. Addition has an inverse operation, that's subtraction. Squaring something, the inverse operation would be taking the square root. So let's say we want to do the inverse operation of an exponent, meaning that I want to figure out what that exponent, how I can rewrite that exponent. So the inverse operation of an exponent is what is called a logarithm. Okay, just some quick notation here. This 2 is called the base. The 5 is the exponent or the power, and 32 is what that all equals. Now, if you're going to go ahead and take this exponential expression and rewrite it as a logarithm expression, what you would do is you would start with the base, and you would go log whatever the base is, and you will hook that around to the other side. So log base 2 of 32, and then the power gets squeezed out or pushed out to the other side. So this whole logarithm expression is what the exponent is equal to. Okay, if we have 3 to the second power, we know 3 to the second power is equal to 9. But let's go ahead and rewrite this exponential expression as a logarithm expression. So you would start at the 3, that is always going to be your base of your logarithm. And you'll hook it around to the other side. So log base 3 of 9. And that 2 gets sandwiched out and pushed to the other side. So the exponent of this expression is equal to log base 3 of 9. The great thing about these is they go back and forth. So let's say I had a logarithm expression. Log base 5 of 25 equals 2. And I want to rewrite this logarithm expression as an exponential expression. Once again, you'll start at your base, and you'll rewrite this as an exponent by going your base and hook it around to the other side. So the base to the exponent is equal to, and then that 25 gets pushed out. So that equals 25. Let's look at one more here. And actually, let's go ahead and try and solve one all the way. Maybe you don't have all the information. So let's say I have log base 4 of x equals 3. And I want to figure out what x is equal to. Well, we can do this by rewriting the whole expression as an exponential expression. So we hook that around. That would be 4 to the third power is equal to x, which means x is equal to 64. There's a lot of uses of going between exponential and logarithm, or logarithm and exponential. One of the biggest uses is being able to solve for an exponent. Alright, so that is essentially the basic of what a logarithm actually is. Remember though that you do have log, you will always have the base, the inside of the log, and then that will be equal to y. And you can rewrite that as b to the y is equal to x. So these two expressions are exactly the same. It would be like saying times 1/4 or divided by 4. Those mean the exact same thing, but there's just two different ways to write it.